Hey folks, we are live. Didn't do a morning session today. I wanted to get my run in before it would be too hot, and then I had to go do some server maintenance. So we're getting a little bit of a late start, but we do have a working server that we can use to run some experiments. So that's nice. That required a full CPU swap and a OS reinstall. We have the whole process of new OS install to having Puffer working down to like 10 minutes though. It's pretty nice. Clean box to working Puffer, it's like 10 minutes. Okay, so we have a lot of stuff to do today. A lot of stuff to do today. Anything here? Oh, this is down again. Which box? Yeah, Linky, we now have a Puffer box 0 up that you can add to the bot. I didn't see this on the bot, otherwise I would have, oh, literally right as soon as I go and get on to stream. This thing is, shows 7 is down. I gotta ask that guy if he wants me to reinstall the box with Ubuntu to see if that's more stable. Because I've been having better luck, I think, with 5 now that we've got Ubuntu on it. Okay. Thank you. So there's going to be some work to do today on this and other things. The main thing I really want to do is I want to have this hyperparameter sweep just running itself in the background without me having to do too much. So I ran these experiments, and I would like to know why this pushes down to minimum cost. Puff login on Ubuntu. I can do that. No, I think Puff login is already on Ubuntu, Link. It's just on an older version. But Puff login should already be on Ubuntu. Unless I reinstalled it, I don't remember. Yeah, you're free to play with that box, though. I mean, if the power goes out, the power goes out, so it's not going to do anything, but... New facility is... do I have this message? Hang on. Let me see if I can find this. Okay, I have a picture somewhere of the electrical wiring that looks pretty cool for the new warehouse, but I don't see it here. Probably in my email or something. So here's what I want to know. This can be made substantially higher, this score over here. It doesn't seem enticed to push out to higher cost, though. Logging, yeah, that's fine. Eventually, the thing is, we're going to get these systems so stable, we're not going to need a ton of logging, but yeah, we have to get there, obviously. I think the container changes will help. 80% disk and 90% RAM. Yeah, see, this cost is so weird. Let's look at all the parameters. So I mean, batch size, this is pretty reasonable, right? It's got some here, it's got some here, this is reasonable. Time steps is the one that goes all the way down. Okay, that's cost related. Learning rate. We kind of need multiple graphs for this, don't we? Here, we'll do this. We're going to be, we become stock trader look-alike for the day with all these graphs. All right, so we'll do this, and then this one will be sample. So we get learning rate, which is 002, looks to be around the best. There are a lot of runs at this learning rate. That's probably the resample. And then what do we have this learning rate? 002 is the center. Yeah, this is pretty good. I mean, this is about what we would want. And then gamma, do we have a gamma? Ooh, 0.9, interesting. We have a lot of min gammas here, though. That's very weird. So yeah, look at all these minimum gamma rolls at the bottom. That's like... I wonder if that's 16.7, so 17.6. Can I find this point? 675. I mean, I guess it gets like a lucky one, and then it, interesting. Maximum gradient norm, 0.6, around here. VF coefficient, 0.8. Max grad norm has a lot of mass on 2. Why is that? M's, yeah. VF coefficient here, 0.8. Yeah, this is fine. It's a little spread, but it's fine. Yeah. And the gradient norm gets up to 1.6, which is here. Yeah, this pushes too high. I don't know why it would push this high. Something's definitely weird here. What about score over time? It got this point relatively early on. Is it just like a lucky point, not resampling? Is this the problem? And so what about cost? I think we're using log cost as the distance at the moment, right? Interesting. Like it doesn't want to put any points out farther. Okay, and if we compare this to the other runs that we have so far, so we've got 53 runs here. Burrito front. Okay, so it's not finding anything better. Is not finding anything better. Also, I don't know if we do, in what space we do the log cost as well. Time to look at the algorithm a bit and see if we can figure out where these issues are coming from. Welcome, YouTube folks. This is currently analysis and tweaks on the new hyperparameter tuning algorithm that we are working on, which it looks like it's going to be a very strong SOTA algorithm, but there are just a few quirks with it, mainly about how it handles which it needs to handle selecting an experiment based on its cost better. It tends to run too many short experiments at the moment. And it's a fine balance because sometimes it's like too many long experiments, too many short experiments, just needs some tweaks. Okay. PufferLib. Here's the algorithm code right here. And I want to see how we're doing the cost at the moment. So we use nearest Pareto distance. This is the term that tells us where on the x-axis we should try to sample. And we use Pareto log C norm, which is you take the cost, you log it, and then you norm it. That's correct, right? Log cost, and then it gets normalized. Okay. So it goes 0 to 1 on a log scale. And it's based on, what's this? Yeah, the current mins and max costs. I mean, so if you have something at 200 and you have something at 400, right? It's going to go 0, 1. Oops, I'm covering this with my head. So this is 0. And then if you have a point here, this would become 1. And then it's like log scaled. That does incentivize you to explore low cost. Huh. It's ironic because I think I did this for the opposite reason, right? If I do, wait, hang on, am I dumb here? I think in my mind, the way that I was thinking about it is that you probably want your runs to be logarithmically spaced out over time. But this is making it way too conservative. Yeah, so I was basically, does that thing even that I was thinking make any sense? I don't know if it does, because I think that what will happen with this log spacing, the way I have it, is you'll get like a point at 800, a point at 800, 2 points at around like 400, so in this region, then 4 points here, and like you get a whole cluster from at the bottom. I could use some sort of baseline. I mean, this works super cleanly on the synthetic tasks though, right? So before I go messing with this, why does this happen? Let me see. Oh, hang on. There's something I missed here, right? So if you don't have a Pareto point to the left of you, yeah, okay, so if you do not have a Pareto point to the left of you, you get the entire, you're rewarded this this much. Where is it? GPT YT norm minus nearest Pareto YT. So nearest Pareto YT Wait, what's happening here? See left. This is the difference between the cost and the Pareto costs, right? And we'll move this as well so it's not covering chat. Difference between cost and Pareto costs. And then any points where the Pareto is going to be more expensive get masked out. But then if everything is infinite, then you end up with just a random point. Which would then make this thing negative, I would think. Which isn't what we want, but should have the opposite effect as what we're observing right now. Do we see this? Is this environment specific, or do we get this on Pong as well? Let me see. Because we have these Pong runs, right? Okay, no, we do get this on Pong as well. Look, this is Pong. The thing is, it's not as bad on Pong because, like, this is kind of where you want to explore anyways. Like, these points out here should probably have gotten a little bit more attention, but I mean, you kind of have the end solved by over here anyways. I think was this one 20.8? Yeah, one of these 2 points is going to be optimal already. And then this massive cluster down here is just ridiculous. Oops. So if we look at this, yeah, it really shouldn't be getting very much for this. Improvements to the way that it works, the improvements to the score close to the top end are way more heavily weighted than improvements towards the bottom end. So it really should not be getting much reward for anything that's down here. But apparently it is. And now we see this on 2 different environments, so that's a trend. You see here a minute. Think about this. Take my supplements now before I forget. Hang on a second. Okay, I'm just taking my supplements now. And then we're gonna think through this. So much work to get one of these algorithms really, really working correctly, but I mean, this is gonna be so huge. Puffer for the field. And assuming I'm able to get this thing tuned a little bit more, which it's performing very well on the points that it's sampling. Like the models that we have, I think are very good, and that is the key, is getting those models correct. But then it's just the way that we use the models. So internally, there are 2 Gaussian processes that I've tuned very well to have quite accurate predictions. That's not the problem. The problem is the scoring function that tells the Gaussian process where to sample based on what it knows at the moment. What are these things? So one sort of thing, one sort of hallmark of a lot of these curves that's kind of confusing to me is why they're this sharp. You know, this really doesn't look like a log curve, you know? Like, look, you get right here, this is 18.7 in 18 seconds, right? But then you go just like a little bit less, and it just falls off completely. I mean, even if we assume that we draw this curve down, this is still, I think this is much sharper than a log, right? This looks way sharper than a log to me. It's like almost like a rounded corner thing. Okay, so another good thing would be score over time. Do we have score over time as a graph? Yes, we do. So this is score over time. So very quickly, you know, we're able to get some good runs here. But then we get all this pollution down here. This I'm not, you know, this I'm kind of okay with. Some of this up here. But then all this is like sort of pollution. Which is pretty weird. Let me go back to looking at that this formula here. Because I thought I was on something with the min cost. It is literally driving down to min cost, isn't it? Yeah, look, total time steps, it's driving it like straight down to the min. It just doesn't get all the way there by the end. But then cost, where's cost? Yeah, you can see this trend. It's driving it straight into the ground. Even over here, like by the end, it's doing these like 15-second runs, even though it's not getting anything out of these runs at all. I mean, I could see that it maybe is trying to fill in this like portion here. I guess let's think about the error case first. So if this sets everything to inf, then this will get This will get the first Pareto cost, which is probably going to be something pretty low, but still, okay. This should always be negative. I'm kind of confused because it should literally never be able to do this. And I don't think that we see this in our synthetic tests either, do we? We can go try it. Let me see. See what the latest version is. These are just synthetic tests I run. I want to figure out if I can see. I want to figure out why it pushes to low cost. If I can figure that out, if I can get that distribution to be reasonable, I think we should be good on the algorithm. I mean, obviously, like, we're going to run this on a ton of different things, and we will see what that results in, but another thing. Cool. Later. Let me pull up a quick web server so we can check this. Okay, so visualize. Excuse me? Method. Really? Something screwy. We will see what is wrong with this thing. I tested this is working, so hopefully there's just something screwy with it. With like a merge or something. It's definitely running the right algorithm though, otherwise it would be instant. That's so weird. This behavior. The thing is, I'm actually like all these points here, I'm kind of fine with, right? Like putting a bunch of points on the elbow is totally fine, especially once you've kind of filled this out. Because the elbow is this like really sensitive area where if you get an accurate estimate here, right, you don't know in practice which of these points you're going to want the most. Like I might decide that this point is the best for me right here, because this one is like pretty well solved, and it's substantially cheaper than this point over here, or this point over here, right? And this elbow can have different shapes, right? So like it could be that if you keep running experiments, you find something over here that's good. So I'm fine with running experiments here, and with any environment that has a little bit of variance to it, you're going to get some points over here that don't do as well. Same thing sort of right here, you know, it's going for, these are ones that have the potential to fully solve. Almost 20.8. But then these ones down here, I don't know what happened. Like this should not be this populated at all. You should get very little reward for stuff that scores this poorly. Okay, so this is the reference curve here. This is with 110 points though, right? So with only 50 or whatever, you're not going to get the full curve. But we can see here that this is expanding out. So let's make sure that this replicates first, so we get something nice like this. And then if we do get something nice like this, we can go from there. Also, let's just make sure this is not actually doing the same thing. No, you see, so we get a couple points here, which is fine. It's filling out the curve at the end once it's done everything else, but you can see that there are still points at the end that are being placed here, filling out this end of the curve, and then quite a few on the elbow. There's like some stuff here. It's not bad. We should also probably like make this plot for we should like add this into the Neptune or whatever. That would be a good thing to do. So we get it for the real environments. So, I mean, I think we can pretty much get this. This is the same plot as. Only thing is not having the color scheme sucks. I really wish that you could apply a color scheme to these points. right? There's like no option or like there's nothing that you can do to change this. It's annoying. I think I emailed them on this as well. They really should add that. It would really make hyperprim sweeps better. Okay, so you can see here you're starting to get full coverage. So, I mean, for a 50 experiment run, this is like what you would want, right? Builds up a nice predictive model. It spends some time on this, and then it starts doing these more expensive runs. Okay, there you go. Not bad at all, right? That's like the same curve from before pretty well. It's not going to be 1-to-1 exactly, but we do this. This is the curve from before. I think this one has some more points. I might have done all 200 experiments on this one. I mean, this is very well filled in. There are only a couple stray points in each of these. Let me see, is there a cluster over here? No, they're like 2 points that are relatively recent. And then right here, is there a cluster over here? 3 points. Well, it did this one. But I can kind of understand these. It's filling in a gap here, right? Yeah, there was a gap, and it filled in a gap. Stupid bots. Get out of here. Okay. And then the percent one was terrible, right? Or is there just something screwy with it? It's up to there. We'll run it. It'd be really nice to speed up the sample speed of this thing. I don't think it Pyro's particularly well optimized. This thing should be very quick to train, instant. I'm actually going to watch this run to see what it's doing, because I'm looking at these ratings on the right hand side. This is how good it thinks each point is at sampling. Okay, like it just found this is a 6. This looks like a good point. Like, why does it only get a rating of 0.6, right? Oh, 6. Yeah, we definitely need to do some work just like on this. So what I think I'll do is I'm gonna, it looks like overall maybe this curve is looking okay here, but the ratings are a bit concerning. Yeah, like look, it pushed all the way out to 25 and 34, 47. It's not getting anything for it. No score's improving. Hundred and 10 experiments, it does fill out the curve. We'll see what it looks like, but I think it'll be fine. And then it'll really be just a matter of looking at this score function to see if it's doing anything that just doesn't make sense. We can evaluate it on the real tasks as well, though that takes a little longer. Dummy, you forgot to switch the task. Okay, there were a few unintuitive things, though, even on here that I think I could look at, right? So we'll salvage this. We're gonna look for the first, like, big cost jump. Okay, so this one here is predicted to get a score of 0.334. Right, 0.334. With a cost of 2.7. And it's only getting about as much as this one here, which has a cost of 1.5, predicted to get 0.25. 1.5 is, this would be the lowest cost point, though. This is the thing. So it's going to get the full score. Okay, fine. We'll look for something more egregious. This is still not particularly egregious. I'm just looking for something where it looks like I would think it should get a lot of score and the function doesn't say it should. Nah, come on, give us a cost jump. I think our best score is like 33.33 at this point, right? Ooh, this got a 0.46. Okay. Okay, so this one should score pretty darn highly, you would think. It does look like it's reasonable. Let's see. 15. Nearby. GPYT norm. Okay. X. Okay, so this is the cost difference. Or the score difference. Is that reasonable? Yeah, I think that's reasonable. It's going up from 0.46. So that's like a reasonable score difference, I would say. And then nearest Pareto distance. Is very small. Predicted. So we have this one, but then the nearest Pareto point should be, what, 2.5 gets 0.41? Pareto log C norm. Oops. GP log C norm. Okay. Log C norm. NumPy min. And this is an absolute value. So it's the 1, I guess, right? Oh no, wait, hold on. Pareto log C norm. Yeah, it's got to be the 1. Okay. You get kind of linear improvements here, don't you? I think I have two functions that are fighting each other. Log and then new norm, right? Oh, right, this one I don't even use. So hang on. What if we do this? Forgot the breakpoint. It's probably something like this that's killing it, the log on the cost. This might make it way too aggressive though. We will see. And so far the score predictions are not bad. They're underfit if anything. So they're conservative. That one's over by a bit. They're generally pretty spot on here. That was a decent number of experiments before it pushed all the way to the top end of the cost, especially for a simple problem like this. This could be better. Now the question is, how much is it going to hang out at the top end? So, I mean, this means that it's going to linearly space all the experiments, roughly. It is still improving the lower part of the frontier, just less. I think this could be worth trying on Pong at least. We'll see what the graph looks like. It's tricky because it also would be interesting to see the compute graphs, I guess. Percent. And that's about what you expect, right? It's like it's going to give you a lot of these points up here. It does still fill in gaps, right? It's like still going to go back to fill in some gaps. I guess we'll have to see what it does on a real environment to know. To be fair, if this one actually does the opposite and it's too aggressive, then we'll know that it's somewhere in between that we want, right? So maybe we'll do that. Yeah, that would actually be a good test. Let's do that. We don't need this extra breakout run. Okay. Then sweep. All right. Oops. DM. I just want to make sure this isn't stuck. And then I will go get some food and we will have some results. You should not be stuck. Let me see. It is possibly getting unlucky. These are the random trials that are started that just start the learning process. I'll give it a few minutes just to make sure we don't end up wasting time on bad experiments. I don't think we changed anything. Oh, with the random search especially. What's it doing? Box? A couple more trials before I get super suspicious. You can get bad randoms to start. What did the random trials look like for this? I mean, they looked better than this, didn't they? Okay, there it goes. Does something at least. Well, I will let this run. It's possible I broke something. I don't think so. You know, this is still random. I think we're fine. All right, I'm going to go get some food. I will be back later in the afternoon, and we will continue on this and other projects. So thank you. If you want to check out my work, it's on puffer.ai. Start the GitHub, join the Discord.